So very good evening to one and all present here. In today's video lecture, we are going to discuss about vernier depth gauge and its significant importance in linear measurements under metrology. So before proceeding to the vernier depth gauge, in the last fragment of the video lecture, we saw about vernier height gauge and vernier caliper. So what is the comparison between vernier height gauge and vernier depth gauge? So the vernier height gauge is used to measure the external height of a given specimen with reference to a particular datum point. Whereas vernier depth gauge, which helps to measure the hollow cavity, depth of a given hollow cavity with the aid of vernier depth gauge measurement. So here there are two different kinds of scales, as like a vernier caliper and vernier depth gauge also. There are two different variety of scales, main scale and vernier scale. So for your reference, I have already shared the video in the morning in your official class group. So you can able to go through the simulation of vernier depth gauge video clips, which is available in your the department, the classroom group. So you can just see the simulation of that. Okay. So in vernier depth gauge, the main scale seems to be a sliding one. So that will travel up and down into the hollow cavity of the jaw. Whereas the vernier scale remains stationary, fixed, that will be rested over the jaw surface. So this is the significant feature of the vernier depth gauge. In addition to that, while performing the depth measurement, what are the common mistakes, the errors that will encounter during the depth measurement process? So these are some illustrative graphs, the diagrams that are represented to show what are the common errors that will influence in the measuring instrument. So let us say figure number A. So according to figure number A, if the anvil of the measuring instrument does not coincide properly, so that leads to parallax error. Okay. So if the sliding scale is not properly fitted to the reference surface due to lag or deviation in the anvil support, we cannot able to get the proper measurement value. See figure number B. Here the anvil are not supported at both the end. So there is a slight drift above the job surface. Okay, this will also lead to parallax error. And the last picture, figure number C, due to tight pressure contact. So when the anvil is tightly compressed over the job surface, so due to the tight pressure point acting on the meeting area, so that will also cause an error. So we have to make a gentle contact over the meeting area. So do not apply tight pressure on the meeting area of the jaw. So keep the anvil gently mounted on the job surface and allow the sliding scale to move downward to measure the reference area, the depth of the reference area. So don't press tightly the anvil support over the specimen surface. So these are the common problems that influence as a source of error in depth measurement process. So further details, you can refer the class group or the video YouTube clips, which I shared in the morning segment. Now, next one, micrometer. So this is also linear measuring instrument which comes under the same category. So micrometer screw gauge is used to measure the flattened jaw, the dimension of the flattened jaw by referring the smaller distance. Okay, so by considering two parallel flat surfaces. So there are different types of micrometer as listed here. One is outside micrometer. Using this micrometer, we can able to quantify the dimension of a spherical shaped jaw, cylindrical shaft-like appearance. Those jaws we can also measure it using outside micrometer, and rectangular blocks, cubical blocks. Okay, these are the different variety of the component we can able to do it using outside micrometer. Inside micrometer, so which is mainly used to rely upon the internal dimension of the jaw, that is inside diameter of the round cylindrical jaw. Then depth micrometer, which is used to measure the hollow rectangular slot or a stepped block. Okay, right? So these are the basic forms of micrometer. Apart from that, there are other specialized classification in micrometer screw gauge as given here. The first one is a universal micrometer. So what is meant by an universal micrometer? So one can able to define the universal micrometer in terms of the anvil setup. So here there are different types of anvil available in universal micrometer. Say flat type anvil. If you want to measure the flattened jaw, so flat type anvil is used interchangeably to find out the dimension of the flat surface for a given jaw. If the workpiece is round, spherical in nature, then you have to interchange the spherical type anvil. Similarly, spline, disc type, blade type, knife edge. These are the different classification of anvil support which is kept in between the workpiece material to measure the size of the jaw. So the term, the universal micrometer, is nothing but versatility. We can do versatile multiple operation using the same single instrument. So what is meant by a blade micrometer? So this kind of a micrometer used to measure the sharp, narrow groove of a machined part. So the anvil will have a sharp edge, blade-like appearance. So that will directly pinpoint into the groove, hollow groove. Okay, so to find out the eligible dimension of the jaw. Next one is the pitch diameter micrometer, which is used to find out the thread pitch diameter of a cylindrical jaw. Next one is limit micrometer. So it is same like snap gauge. Okay, so using limit micrometer, so we can able to find out the tolerance between the minimum and upper maximum dimension. So we can able to justify whether the machined part lies within the maximum or minimum value within the tolerance value. So based on the specification, so we can decide whether the part is good or not. So next one is a bore micrometer. So it has three different type of an anvil head, so which is accurately used to measure the hollow profile for cylindrical jaw. The last one is a tube micrometer. So it is used to measure the thickness of the jaw, the flat jaw. Consider a flat jaw. If you want to measure the thickness of the flattened jaw, so the tube micrometer is used. So these are the different classification under the micrometer screw gauge. Now coming to the construction of micrometer. So the following are the basic parts of the micrometer as given in the pictorial illustration. So the micrometer screw gauge has a C-type frame which is rigidly connected to a barrel and a thimble scale assembly. And there are two anvil supports which is used to hold the sample workpiece for resting. And next thing is a barrel. It is a long cylindrical arrangement, so which has a graduated scale reading. You can see here a barrel. So this is called as a head scale reading in a micrometer, which has a graduated scale mark. Next one is the spindle, which is which seems to be look like a cylindrical bar, which is directly coupled to the thimble. So this one is a spindle, okay, which is directly coupled to the thimble scale for flexible movement, forward and backward movement. Then last one is a ratchet stop. So the purpose of ratchet stop is to limit the applied pressure when we are turning the thimble scale in order to contact the job between the two anvil end. So the ratchet stop that indicates the limiting pressure to tighten or grip the job for performing the measurement between the two dead ends. See in the picture you can able to notice these are the two dead ends. In between the two dead end, the material will be placed. And this one is the ratchet stop. By rotating the ratchet stop continuously, so this spindle will be moving forward in order to have a point of contact over the job surface such that once the spindle tightly supports the job material, so we want to stop the ratchet by a controlled applied pressure by producing a noise, so that initiates the surface get gently packed between the two end. So this gives about the parts, the construction details of micrometer. So with this, I conclude the today's the video lecture. So the supporting animation, the video clips related to different kinds of micrometer, that also shared in your official class group. So you can see both my video lecture and also the animation clips. So, and try to clarify the doubt in the meanwhile. If you come across any ambiguity in the concept, please you can come and contact at any point of time. So thank you. Thank you one and all.